Assalamualaikum. My name is Muhammad Harith bin Zulkarnain from Section 1/2 BET. Today, I and my groups will present our mini project assignment, which is automated car parking with empty slot detection. So my group is Muhammad Harith bin Zulkarnain, which is me from Section 1/2. Second, Muhammad Farhan bin Prayitno from Section 1/2. Third, Muhammad Zahir bin Saimon. And last, Azalie bin Jone. So for now, I would like to present the problem segment and background of this project. So the introduction: finding a parking lot in most of the metro cities is a tedious job which consumes a lot of time and wastage of fuel. The automatic parking system provides a remote facility to a user to find a parking slot for a vehicle. There is a need to embark upon an investigation on how to design and simulate an electronic automobile parking control system. Some years back, people and organizations use heavy metal gates which require the use of human strength to open or close their garage. After the advent of digital electronics, much problems were overcome in many countries, including the problem stated above. In this research work, the design, implementation and simulation of an electronic automobile parking control system using discrete components that has the capacity of 120 parking spaces is presented. The design was carried out and implemented using simulation software which is multi-sim. However, the project is limited for only 120 cars into 120 capacity parking garage. The system is mainly for public and private parking, where many cars up to 120 are expected to be parked, where sensors are designed to detect only cars. Barrier at the gates will remain open, which is raised until the counter counts to 120, then it will be lowered to block further entry. So for the background of this project, digital systems are created to perform data processing and control tasks. Architecture talent is what distinguishes one system from another to efficiently execute the task for which it was designed. Today, digital technologies are dominant because digital systems are easier to design, accurate and precise. Also, information are stored easily and portably in digital systems. The main building blocks of automobile parking control system are the sequential device like up or down binary counters, combinational device like logic gates. Other include 7-segment LED display for display and sensor, the up or down counter which is a negative edge triggered is operated using SR latch or any other 555 timer that fits.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Farhan bin Prayitno, and today I would like to show you my part for our mini project for the automated car parking system. So today my part is to present the truth table and the block diagram for our mini project. So this is, as you can see here, this is our truth table of KSR latch. The enabling input is 1111. Gather input is there's a two gathered input which are S and R. Where S as you can see 0, 0, 0, 1, 1, 0 and 1, 1. The latch input also 2. As the gathered input is 2, so the latch input 1, 1, 1, 0, 0, 1 and 0, 0. This is the output for the queue for our mini project here. And see means no change condition. 0, 1, 1, 0, and 1, 1. Where when the get input is 1, 1, is 1, or one of the input is 1. So then we move to the block diagram. As you can see here, the block diagram start with the power supply, and we got two sensor here with entrance sensor and the exit sensor. When the car start to get into the parking and get out of the parking, so we use the counter, where two counter here with up and down counter. Then we go to the interface and the motor control to control the system, and the gate will be up or the gate will be down. So this is the block diagram. But last but not least, this is the figure for we use this 74HC190 up or down decade counter. As you can see, as we all know, an up or down counter, also called a bidirectional counter. You can see bidirectional counter. It's a counter capable of progressing in either direction to a certain sequence. Here. This is the output. This is the input. It can have any specific sequence of states. Sorry. Up or down counter also come in an integrated circuit IC. Integrated circuit IC. As you will know, one good example of this counter is we use this counter type which count both directional, where one directional here and one input here and one input here. So it can count in both direction. The direction of the count is determined by the level of the up or down input D. That's it. The direction of the count is determined by this D0, D1, D2, and D3. When the input is high, so the counter counts down. When the input is low, the counter counts up. It's easy for us to understand it. So this figure 3 for the 74HC190 up or down decade, the count, enable input, and ripple clock output are used when cascading counter. Means the maximum or minimum output produce a high pulse when the terminal count 9, 1, 0, 0, 0, 1 is reached in the up mode, or when the terminal count 0, 0, 0, 0, 0 is reached in the down mode. So this is the decade counter we use here. So I think that's all from me. Oh, I forgot. Maybe I forgot. My name is Muhammad Farhan bin Prayitno, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okey, saya kat sini nak terangkan tentang data yang saya buat, function dia. Okey, saya buat circuit untuk automatic car parking service. Maksudnya kita boleh tahu maksimum berapa yang kosong di dalam car parking tu lah. So, saya buat kat sini maksimum dia pergi 120. So, yang ni dia punya entrance. Yang ni bila keluar. Maksudnya setiap kali kereta masuk, dia akan keluar kat sini. Berapa biji ada dekat dalam parking garage. Dan keluar, dia akan kira juga. So, bila ni maksimum, bila saya masuk dah tak ada apa-apa, saya restart balik. So contoh bila saya masuk satu kereta, dia akan kira dekat situ 1, 2, 3. Setiap kali kereta masuk dia akan kira. Dan maksimum ialah 120 buah kereta. Dan ni ialah bila dia keluar, dia nombor akan turun ke bawah. Setiap kali kereta keluar ataupun sensor detect, dia akan masuk dan keluar. Okey, itu saja.
So the conclusion for this project, for this mini project, is this design of 120 capacity automobile parking control system was successfully carried out using synchronous decade up or down counters and logic gates, sensor and DC motor. The design was implemented and simulated using multi-sim simulation software. The result of the simulation indicates that the system functions are desired, where if the full capacity of 120 cars are parked in the parking lot, the gate closes and wait for an available space before the gates open for additional cars to enter. The available space is always determined by the number of cars that leave the garage. So this is the conclusion for our mini project. Lastly, this is the list of everybody's function to accomplish this project. So that's all for our presentation. Thank you for watching.